Hello, welcome back. Today we're going to be talking about writing equations of lines in point-slope form. The objectives is that by the end of this video, you should be able to write the equation of a line in point-slope form if you're given a point and the slope, 2 points, or a graph. The point-slope form of a line, as the name suggests, is a linear equation that tells you the slope of a line, m, and a point, x1, y1, that the line passes through. Here's the equation. Y minus y1 equals mx minus x1. M, just like when we were talking about the slope-intercept form, still stands for the slope of the line. The y1 is the y value of a point that the line passes through, and the x1 is the x value of a point that the line passes through. We're going to be asked to write the equation of a line in point-slope form that has a given slope, in this case our slope is 5, and that passes through a point, in this case -2, 7. So how do you do it? First thing you're going to want to do is write the point-slope form. So let's go and do that together. The point-slope form is y minus y1 equals mx minus x1. So we've written the point-slope form. Then we need to substitute in the y1, the m, and the x1. But where do you get the y1, the x1, and the m from? Well, the x1, y1, those are going to come from our point, x1, y1. Since we only have one point, we denote that that's our first point by making it an x with that smaller 1 down below, and y with that smaller 1 down below it as well. So x1, y1 stands for the first, and in this case, only point that we're given. But what does the m stand for? Well, the m should stand for the slope. So we have the m, we have our x1, and we have our y1. So we can write the equation of our line. Y minus, where's our y1? Our y1 is 7. So y minus 7 equals, now what's our m? Our m is 5. X minus, what's our x1? Well, it's a -2. So we've written the equation of a line in point-slope form by writing that our point was x1, y1, writing that our slope was m, and then substituting that x1, y1, and the m into the point-slope form. We can simplify this a little bit further because that minus a negative can be written as plus a positive, or x plus 2. It's important to note how the equation changed the -2 to a 2 and the 5 to -5. If we look at our original point, it was -2 on our x value. When we go down to the equation, because it was minus -2, it turned it into a plus. The y1 was a 7, and when we put it into the equation, it became y minus 7. That's going to be important later on. Go ahead and give this one a try. Alright, just like in the previous example, it'd be a good idea to write the point-slope form. Y minus y1 equals mx minus x1. Then we need to find our point, x1, y1, from the point that we were given, and our slope, m is 2. Then all we have to do is substitute in our values. Y minus, our y1's -2, so we're going to write -2, equals, our m, which is our slope, is 2, so we write 2. X minus, what's our x1? Well, our x1 is 3. So, gives us y minus negative 2 is y plus 2 equals 2, x minus 3. Again, the minus negative became plus a positive, which we can write just as 1 positive 2. Again, please notice how the signs changed the point from positive 3 and a negative 2 to when we put it in the equation to a negative 3 and a positive 2. Here's one more of this type for you to try. It's a little weird because your point is 0, 0, so it's going to affect the equation a little bit. Again, go ahead and give it a try, pause the video, and press play when you're ready to see the answer. Hopefully you made it this far. You got y minus 0, since that was your y value, equals 1, which is your m, your slope, parentheses, x minus your x1 was also 0. We can simplify that further. Y minus nothing is just y. 1, x minus nothing is just x, leaving us with y equals 1x, which is just x. This one's a bit weird because it gives us our linear parent function, which passes through 0, 0. Suppose we were asked to write the equation of a line that passes through 2 points, negative 2, 5 and 4, 7. Now, how would you do that? Well, if we write the equation in point-slope form, all we need is a point and a slope. Well, we're given 2 points to choose from, so we can use one of these points for point-slope form. But how do we find the slope? Let's take a look. We're given 2 points. I'm going to name my points x1, y1, since that's the first point, and x2, y2, since that's my second point. And then I can substitute those values into my slope formula. y2, which is 7, x2, which is 4, minus y1, which is 5, over x1, which is negative 2, is equal to, in the end, 7 minus 5, which is 2, over 4 minus negative 2, minus a negative is plus a positive, so 4 plus 2 is 6, which we can reduce by dividing the top and bottom by 2, giving us, in the end, a slope, or an m value of 1/3. So we have an m, and we have a point. Now we can find the equation of the line in point-slope form just by substituting in our m value and our x1, y1. So again, we write the equation of the line in point-slope form, y minus y1 equals m, x minus x1. We substitute in our y1, so y minus 5 equals our slope we found out was 1/3, x minus our x1 is negative 2. So this gives us y minus 5 equals 1/3. X minus negative 2 gives us x plus 2. This one was a little bit more challenging because we had to find the slope from the 2 points first and then substitute the slope and our x1, y1, our first point, into the equation. Go ahead and try this one on your own. Write the equation of a line that passes through 1, negative 3 and negative 6, 9. I've written the slope formula and the point-slope form down below for you. Again, you're going to need to find the slope first and then substitute in your x1, y1. Alright, I went ahead and labeled my points x1, y1, x2, y2 for my first and then my second point. And then I got 9 minus negative 3. 9 minus negative 3 is 9 plus positive 3, which is 12, over negative 6 minus 1, which is negative 7. So we have our m value, which is our slope. Now we need our x1, y1, which we're given. So we can write our equation, y minus y1, which is negative 3, equals m, 12 over negative 7, which we can write as a minus out front, 12 over 7, x minus x1, which is 1. Simplifying, we get y minus negative 3, which is y plus 3, equals negative 12 over 7, x minus 1. And we've written the equation of a line in point-slope form given just 2 points. Suppose you were given a graph. Write the equation of the following line on the graph. Well, we've done this before. We've done this with slope-intercept form. But why would it be difficult to write the equation in slope-intercept form? Well, the answer is we're not given an intercept. So perhaps we can use the new form that we found. What do we need to write in the equation in point-slope form? Well, we're going to need a point on the line, and we're going to need the slope of the line, which we can find. Let's take a look and see if we can find a point on the line. Remember, the points we want are where the line crosses through the corners, and here's a good spot right here. This is the point x, which is 1, and our y1, which is 2. So the line passes through the point 1, 2, because that point is on the line. So our point is 1, 2. This will give us our x1, y1. But what about the slope of the line? Well, if you remember, you can find the slope of a line by using rise over run. So I'm going to make our x1, y1 our starting point. And I'll make this point down here our ending point. So our rise is a negative 1, 2, 3. So it's a negative 3. And our run to get to the second point is a positive 1. So again, our rise, negative 3, and our run is a positive 1. So our slope, again, slope being rise over run, is going to be negative 3 over 1. Now, negative 3 over 1 can be reduced a little further, giving us finally our m equal to negative 3. So we have an m, we have an x1, y1. Well, we can write the equation of the line then, just by substituting in the m and the x1, y1. So we're going to get y minus the y1, which is 2, equals our m, which is negative 3, x minus our x1, which is 1. And now we've written the equation of a line from a graph using point-slope form. Go ahead and try this one on your own, pressing pause, and when you're ready to see the answer, please press play. The first thing you want to do is find a point on the line. So I'm going to look, and I could choose this point, 3, 0, or I could choose this one up here. I'm going to choose 3, 0. So the point that I chose was 3, 0. If you chose a different point, I'll rework the problem here in a second, starting with that other point. Either way, your slope should have been a positive 2 rise and a positive 3 run, which means your slope should have been 2 over 3. So the equation of the line then would have been y minus y1, which was 0, equals m 2/3 x minus x1, which was 3, giving us y minus 0 is just y equals 2/3 x minus 3. Now, suppose you chose a different point. Suppose you chose the point 6, 2. Well, all that does is change how the equation looks. It's going to be y minus the y1, which is 2, equals m 2/3 x minus the x1, which is 6. So you might be wondering, which one's right? The answer is they're both right, because both of these equations, when graphed, will give you this line. So it really doesn't matter which point you choose. I suggest you choose the point that you like or that makes the most sense to you. Go ahead and try this problem again on your own, writing the equation in point-slope form of the line that you're given. Okay, it looks like a bit of a mess, but there were 4 possible answers based on the graph you were given. Y minus 3 equals 1, parentheses x minus 4. Note, the 1 isn't necessary, and a better answer really is just y minus 3 equals x minus 4. But if you write the 1 for now, that's okay. We're going to be doing different stuff with these equations later. Y minus 2 is another possibility, equals 1 x minus 3. Y minus 1 equals 1 x minus 2. Or y equals 1 x minus 1. Any one of these answers, which I've tried to color code for you, is correct.